Hello everyone, welcome back to our channel. Let's discuss the next name reaction, that is Blanc chloromethylation. See the statement. Introduction of chloromethyl group onto the aromatic rings using formaldehyde and HCl in presence of Lewis acid as a catalyst is commonly called as Blanc chloromethylation. Methylation means introduction of methyl group, right? Chloromethylation means replace one of the hydrogen with Cl, that is chloromethyl. So simply we need to take one organic compound. Organic compounds should treated with formaldehyde and HCl in presence of a Lewis acid. We can take any one of the Lewis acid. Then what happens? One of the hydrogen on the aromatic ring will be displaced with CH2Cl. So simply introduction of CH2Cl group on the aromatic system. Replacement of the hydrogen on the aromatic system with CH2Cl is commonly called as Blanc chloromethylation reaction. Simply you need to put it into your account that whenever you want to introduce CH2Cl group on any kind of aromatic system, it may be a benzene or it may be a heterocycle one, pyridine, right? In heterocyclic compounds also we can create CH2Cl group by using this Blanc chloromethylation reaction. Okay, so let's see the equation. What is the equation? Benzene, HCHO, ZnCl2, HCl, one hydrogen is replaced with CH2Cl. In organic chemistry, the mechanism is the important portion, right? Let's see the mechanism. We all know that mechanism of organic reactions are very simpler. See, here what are the reactants? Benzene, formaldehyde, HCl in presence of Lewis acid. So Lewis acid here acts as a catalyst, right? In generally what happens? The catalyst can enhance the rate of the reaction. In generally catalyst doesn't wants to participate in a chemical reaction. If it is participating, the condition is that it should be removed at the end of the reaction in the form of something else, right? Let's see what happens. Initially we have taken formaldehyde. Formaldehyde is going to react with zinc chloride. Already we know that we have a vacant orbital at the zinc chloride. That's why it is an electron deficient center. So electron deficient center needs electron rich group or not. If you see the formaldehyde, here we have oxygen having two lone pair of electrons or not. So whenever there is the availability of the electron deficient center, what happens? The lone pair of electrons will be donated to that electron deficient center. Thereby what is happening? The oxygen will take the positive charge. The zinc is receiving the electrons. That's why zinc will take the negative charge by the formation of oxygen zinc bond. Clear? Now see. Oxygen is having the positive charge means it is electron deficient center or not. In order to remove its electron deficiency, what is happening? These pi bonding electrons are shifting towards the oxygen. Why? Because oxygen is more electronegative than the carbon. That's why these electrons move towards the oxygen itself. That's why we are creating a negative center. Already positive center is there. The positive and negative both will be neutralized or not. But here what happens? The carbon will get the electron deficiency. So that see HCO minus ZnCl2 minus. So HCH positive charge. So now we are having a positive charge on the carbon or not? So why we have created the positive charge on the carbon? Because we need to introduce a carbon center at the aromatic ring system. That's why it is necessary to create the electron deficient center of the carbon. right? Now what is happening? These pi bonding electrons are moving towards the carbon. It means these pi bonding electrons moving towards this carbon will take the negative charge. Once it is taking the negative charge, means this will take the positive charge or not? This is the positive center, this is the negative center. The negative center is connecting C plus and forming the bond, CC bond. CH2 group is there. CH2O ZnCl2 minus. So here we have positive charge. Here what is happened here? The benzene ring loses its aromatic character or not? So in order to retain its aromatic character, what is happening here? The hydrogen is removed in the form of H plus for the fulfillment of the aromatic character, complete delocalization. See this, here it is formed CH2O ZnCl2. Okay, now we have minus charge on the zinc. To neutralize this charge, the chlorine is removed in the form of Cl minus. So thereby we are creating positive charge or not? The minus and positive charge will be neutralized and come up with OZnCl. Okay, this is finally treated with HCl. HCl means H plus and Cl minus. This bond is subjected to breakage. Thereby oxygen is more electronegative than carbon. So these bonding electrons moving towards the oxygen. Oxygen will take the negative charge. Carbon will take the positive charge. So Cl minus will approach here. We will come up with CH2Cl. So O minus receives H plus. So it is going to be removed in the form of ZnOHCl. So in this way we can replace the hydrogen atom on the aromatic system with CH2Cl group. Very easy or not? Let's see the applications of this reaction. Here the first application is that the same example we have taken. Here the condition is that when concentration of benzene is more, suppose if we have unreacted benzene in the container, what happens? The unreacted benzene will be treated with the product. Here the removal of H and Cl takes place to produce this kind of a byproduct. So that's why whenever we do the chloromethylation, we should consider the number of moles of involvement of that aromatic compound. If you increase the number of moles, automatically along with the product we will come up with a byproduct also. The second point in this one is, in some cases in the examinations, the people will give along with the benzene, they will not give formaldehyde, they will give 1,3,5-trioxane. What happens? This is the structure of 1,3,5-trioxane. The 1,3,5-trioxane will be decomposed in presence of H plus ion into 3 moles of formaldehyde. So it is the compound which is generating the formaldehyde indirect way. That's why in place of the formaldehyde, in some reactions we can observe 1,3,5-trioxane. Simply conversion of aromatic compounds into its corresponding chloromethyl derivative. Okay, see the next example. Here we have OCH3 and isopropyl group. Both are the orthopara directing groups or not? But the more influence is with this one. That's why ortho is occupied. So we need to have para position. So at para position CH2Clu is introduced. Already we know that naphthalene involving in the electrophilic substitution. The electrophilic substitution takes place at the alpha position. All alpha positions are similar. So at any one of the alpha position we can introduce CH2Cl. In case of this one also, OCH3CH3, this is the orthopara, this is also orthopara directing group, but this one is more dominated. So with respect to OCH3, this is para position already occupied, so ortho position is vacant. At ortho position CH2Cl is there. So in this case also similar situation. This group is the bulkier group, this is influencing. With respect to this group, we are getting CH2Cl. So in this way, we can replace the hydrogen atom on the aromatic systems with the CH2Cl group. Okay, thank you very much.